Section 3.3, Chapter 3, Section 3 is all about solving inequalities, but now we're using multiplication or division to solve it. So still one-step inequalities, but we're going to use multiplication or division. So our learning target here, or our objective, is to use multiplication or division to solve inequalities. So how are we going to do that? Let's look at a little bit of a review first. Since we're talking about inequalities, one thing that you need to know about inequalities is how to graph them. Graphing a number is one thing, but graphing an inequality is another. So this one says x is less than, remember you know that that is less than, looks kind of like an L, 2.5. So we're going to have 2.5 on there somewhere. But let's do this. Let's have 0, 1, 2, 3, 4, and I'm going to use blue now. 2.5 would be right about here. So it's less than, so it's going to be open circle. It is not less than or equal to. If it was less than or equal to, you'd fill in the circle. But x is less than 2.5, so anything less than 2.5. Going that way. So that's how you graph that inequality. And the second inequality is a little bit different because the variable is behind it. It's on the other side. So this negative 4 is less than or equal to m. So we're going to, first of all, we're going to rearrange it so that the m is in front. Always rearrange it with the variable in front. So m is in front, negative 4 is in back, and you switch the whole sign around too, so it's greater than or equal to. All right. Now we are going to put some numbers on this number line. We know negative 4 has to be on there. So we'll put negative 4 over here somewhere. Negative 3, negative 2. I don't know what's going on here. I must have hit something. Negative 2. It'll keep going down that way. Or, I mean, that's technically up. Negative 5. As long as you have a few numbers around it, we know where we're at on this number line. Different color again. M is greater than or equal to negative 4. So on negative 4 could be greater than or equal to. So we are going to fill it in because it could be equal to that number. But if it's greater than or equal to, it's filled in circle going to the right. So that's how you graph. Next question. What is the addition property of inequality? Hopefully you remember what it is. That was one of our first lessons, maybe last section for this chapter. The addition property of inequality is just like the addition property of equality, only we're using inequalities. I'm not going to go through this whole diagram, but if you add something to both sides of an inequality, the result will be an equivalent inequality. How that looks would be like this. Let's say, here's an example, x minus 4 is less than 2. The reason we use the addition property of inequality for this is because we'd have to add 4 to both sides to get rid of this minus 4 so that the x can be all alone, and then x is less than or equal to, or less than 6. So basically the addition property of inequality says it's legal to add the same thing to both sides of an inequality. Now that leads us into the subtraction property of inequality. It's the same thing, only you can subtract something from both sides of the inequality without messing everything up. So here's an example where we would use that. And maybe you can come up with your own, but x plus 4 is greater than 2. We'd have to subtract. This says it's illegal to subtract something from both sides so that the x is all by itself, and 2 minus 4 is negative 2. X is greater than negative 2. All right, we're going to go on from there. We're going to actually talk about the multiplication and division property of inequality. But I'd first like you to look at this box, this table. It says fill in the blanks. 4 times 3 and 1 times 3. So 4 times 3 is 12. And 1 times 3 is 3. So 12 is greater than 3. Okay. 4 times 2. Whoops. 4 times 2 is 8. 1 times 2 is 2. So 8 is greater than 2 again. 4 times 1 is 4. 1 times 1 is 1. Greater than. Alright, now we're multiplying by negative. Negative 4. And negative 1. Now it switches. Interesting. So we're multiplying. We still have the 4's and the 1's, but when we're multiplying by negative, we have to switch the symbol because negative 4 is actually less than negative 1. If you look at a number line. Negative 8 is actually less than negative 2. Negative 12 is actually less than negative 3. So the multiplication property of inequality looks like this, where you can multiply something by the same side, or on both sides without changing it. But if you multiply by negative, you have to switch the symbol. So we're going to put that on there. If you multiply both sides by a negative number, you must switch the, or we'll say flip the symbol. All right, and that's interesting. All we had to look at was a pattern there. That's why I love math. Everything comes from patterns. You can look for patterns. You can create patterns. Patterns. So to put it into words, the multiplication property of inequality says you can multiply anything to both sides of an inequality without changing the solutions. And then I say except for the negative rule. So we're going to call this the negative rule. It really is the negative rule of inequalities. And I'll give you two examples here to work with where you'd have to use the multiplication. Maybe you can come up with your own. But remember, to use multiplication, you'd have to have division that you're trying to undo. So we're going to do x divided by 4 is less than or equal to 3. And then I'm going to do m over negative 3 is greater than 2. So this first example, we can use the multiplication property of inequality. Remember, we multiply this side by 4, or 4 over 1. So that these cancel out, and you just have x over 1, which is just x. But then you multiply this side by 4. Less than or equal to stays there, and that's actually a 12. I can't even multiply here. What is 3 times 4? It's 12. So x is less than or equal to 12. That's it, just using multiplication. Now the second one you might see is a little bit different because you have to multiply both sides by negative 3 to cancel that out so that the m is by itself. Multiply this side by negative 3, which is negative 2 times 3, negative 3 is negative 6. Now the symbol flips because of that negative rule. If you multiply both sides by negative, you flip the symbol, so it's going to be less than. M is less than negative 6. All right, let's finish it up with the division property of inequality. Division property of inequality is just like the multiplication property. And the negative rule still comes into play. So you can divide anything to both sides of an inequality without changing it, except for that negative rule. So let's look at this. 4n is greater than or equal to 10. And I'll give you another one. Negative 2p is less than 1. So, by the division property of inequality, we can divide both sides to get the n by itself. So we're going to divide by 4 here. So the n is by its... Now I just changed it to an m. Just like magic. But it is an n. Divide this side by 4. 10 divided by 4. What happens when you divide 10 into 4 parts? Well, if you divide it into 2 parts, it's 5 each. And then you divide those by 2, and you get 2.5. Alright, and the symbol does not change because there were no multiplying or dividing by a negative number. Now the second one here, we'd have to divide by negative 2 on both sides. So the p is all by itself. This would be negative 1 over 2, so negative 1/2. And with that negative rule, we must flip the symbol. So p is greater than negative 2. All right, that is the division property of inequality. And we are going to skip this next thing, and I'm going to just want you to think about this. And I'm not going to make you do it on a half sheet of paper right now, but I want you to think about this question so you can answer it next time. Write in words the steps you would take to solve the inequality below. Not just showing me the steps. I want you to write it in words too. Okay, it might help to write it out, write the steps out first. But I want you to think about that one as we finish up this lesson on the multiplication and division properties of inequality. Think back to your goal. Could you meet that goal now on your own? All right, have a great day.